Hello everyone, my name is Ben and you're watching Uncharted X. This is a continuation of part 2 of my multi-part series investigating the mysteries and contradictions of the incredible Serapeum of Saqqara in Egypt. If you haven't seen the earlier chapters, I'd recommend you do so before watching this, and they're linked in the description below. In this video I'll take a closer look at the quarrying and construction of the mighty 100-ton single-piece boxes housed in this mind-boggling underground labyrinth, and in particular we'll dive into the many aspects of precision that are evident in their construction. Precision that is irrefutably impossible to achieve with the simple tools and the primitive methods ascribed to the dynastic Egyptian civilization. And it shows what I think is solid proof that these objects could only have been manufactured with high technology means. Majestic as it was, the ancient Egyptian civilization as we knew it simply did not have the means or capability to manufacture these boxes. They most likely inherited them, along with the site itself, and renovated and repurposed it. I hope to show why this site and these astonishing boxes are simply begging for some real, open-minded scientific investigation. So if you think that goal is a good idea, please help me to spread the message and drop the video a like, and remember to subscribe to my channel for more videos like this one, and to hit the bell icon so you get notified when the next part in my Serapeum series drops. So when you decide that you want to make one of these giant single-piece stone boxes, the first challenge you face is the quarrying.
This is how they made them, apparently.
Watch out, you'll break it.
Once you've found your granite quarry, and typically these aren't on flat ground, they're either parts of mountainsides or up large hills. This is true for Aswan, which you can see here. The large solid pieces of stone that you can cut these boxes from aren't on the surface of these quarries. Quite often these are fairly deep underground. You might have to go 10 to 15 meters down through granite to find a solid enough piece of stone from which you can make your single piece block. Assuming you can cut this block away, you are now faced with lifting this block up out of the quarry, and we are talking about blocks here that are probably in excess of 150 to 200 tons. And that figure pales in comparison next to objects like this, the unfinished obelisk still in Aswan, which is estimated to weigh around 1,200 tons. And it too would need to have been lifted up out of the quarry before it's taken anywhere. Remember that the lids from these boxes are typically cut from the same piece of stone, and you haven't hollowed out the inside of the box at all, you're just dealing with the raw weight of the material. We know this because of pieces like this one, which is another precision granite box, albeit much smaller than the ones in the Serapeum that's housed in the Cairo Museum. And on the back of this box, on the underside, you can see where they have gone to cut the lid off that single piece of stone and then abandoned the effort after that slab of stone evidently broke away. This is a very interesting box in its own right. There are lots of boxes that match the criteria like the ones in the Serapeum, and this one shows all sorts of different signs of very advanced machining techniques. And I'm going to get into some of these other boxes and their relationship to the ones in the Serapeum in later parts of this series.
This line here is a clearly red paint.
Yeah.
But this one is mysterious. It's darker. It looks like it's lower than the rest of the surface.
Yeah.
And it looks like the stone is melted. And this could be a type of a very advanced machine.
So assuming you can now lift that up out of the hole in the quarry, move it down the hillside, you can now put that thing on a boat and ship it up to the site. While some of these boxes no doubt came from Aswan, which is some 500 miles to the south from Saqqara, and connected via the Nile, so shipping them on the boat is a possibility, many of these boxes did not come from Aswan, which was primarily a quarry for pink or rose granite.
We doubt that this is coming from. We doubt that this is coming from Aswan, by the way.
No, this is a Sinai stone.
This looks like more like navigation channel. Huge.
Yeah.
The most likely place for the quarries for these boxes was the eastern desert of Egypt. And there are no rivers connecting the eastern desert to Saqqara. You're talking about hundreds of miles of mountains and deserts and obstacles and terrain that you now have to move this massive piece of stone across. What's even more intriguing is that there is a lot of evidence that suggests these boxes were actually finished down underground in this crazy tight environment. Now, I can't imagine trying to work this type of stone in that type of environment. The dust that it would generate, the machinery that must be required, and even just the manpower if you assume it was done by hand, it just doesn't seem possible that you could fit any of that down into these tunnels to do that kind of work. As an example, let's take a look at how we work with granite today. In our granite quarries, we use explosives to remove large chunks of granite from the hillside. We then use giant machinery to move around these huge blocks. Once we have our blocks in place, we cut them with gang saws or with giant circular saws that are under tremendous hydraulic pressure, and they are constantly being lubricated with advanced slurries, typically carbon silicate and incredibly hard materials. And even then, we have to make multiple passes, and it takes a lot of time to cut through granite. And what's most interesting about our granite quarries today is that none of it is really at the same scale of what we're looking at when we look at ancient Egypt. We don't work with blocks this big. Typically, we have much smaller blocks and we cut slabs from those blocks. We don't have the type of machinery that it takes to, for example, hollow out the insides of these types of single blocks of stone. So what would it take for us to create a box like this? I certainly think it's within our capabilities, although we've never actually done anything like this as far as I can tell. Christopher Dunn is a manufacturing engineer with over 50 years of experience in the aerospace industry, primarily dealing with precision and laser instrumentation. He's written a couple of excellent books on ancient Egypt, and it's from his work that I derive a lot of my inspiration on this topic. I'd recommend reading his website as well as looking into his books. But he actually tried to have one of these boxes made, or at least he contacted a granite manufacturing company in 1995 and provided them the specifications for one of these boxes, and it was just for the box and not including the lid. This is the response he got, to quote, "You mentioned to me that the box was derived from one solid block of granite. A piece of granite of that size is estimated to weigh 200,000 pounds if it was Sierra white granite, which weighs approximately 175 pounds per cubic foot. If a piece that size was available, the cost would be enormous. Just the raw piece of rock would cost somewhere in the area of $115,000. This price does not include cutting the block to size or any freight charges. The next obvious problem would be the transportation. There would be many special permits issued by the DOT, and it would cost thousands of dollars." End quote. So that's a price from 1995. I imagine the cost would be significantly higher today. So in further quoting Christopher Dunn, quote, "Mr. Leither goes on to say that Truestone did not have the equipment to create this box, and that they would have to create it in 5 pieces, then ship it to its destination and bolt it together on site." End quote. We can conclude from this interaction that creating this type of an artifact from a single piece of stone, while it might be possible for us, would require a tremendous amount of effort and obviously a tremendous amount of dollars. It would likely require the construction of specialist tools that would all require machine guidance and hydraulic pressure, and then the software and custom bits and pieces to drive it. In other words, lots and lots of effort. Transporting the box is its own special kind of nightmare, and that's just for one box, not including the lid, and certainly not repeating that process 24 more times. The challenges for an ancient civilization to achieve this are already stacked pretty high, and we haven't even started to discuss the nature and depth of the precision that is evident in these objects. I want to talk about the nature of precision for a moment, because I don't think this is a concept that everyone is totally intimate with. Fully grasping the actual nature of precision, and in particular its relationship to function, is an important aspect to fully understanding what is going on with these boxes. We all deal with precision to some degree or the other as part of our daily lives. Maybe you're building a computer from scratch, or you've bought some furniture or a tool set, or something like that that has those 3 dreaded words attached to it, some assembly required. And you find that one of the drill holes is off by about 1/8 of an inch, thanks to the Chinese workshop that made it from a template. And you quickly begin to grasp the relationship between precision and function. Now, while that's an example we can probably all relate to, the relationship between precision and function becomes vastly more important and exponentially more difficult when you start talking about things like the aerospace industry, medical equipment. Let's think about electronics and actually semiconductor chip fabrication, which happens in the nanometer scale. Developing this level of precision is an extremely expensive process. You simply do not embark upon it for any other reason than a specific function that you're chasing. Having the ability to create circuitry at nanometer levels is only sought after in order to achieve a specific function. In that case, packing millions of transistors and logical circuitry into a tiny little power-efficient footprint. So when it comes to things like artwork or symbolic objects or ritual objects, honestly, just making sure it's pleasing to the eye and coloring from within the lines is generally going to be sufficient. When you start talking about degrees of precision that require in themselves the manufacture of extremely precise measurement tools in order to even fathom the degree of precision that you're looking at, such as this 18-inch precision straight edge that I'm holding, you're talking about an area of precision that is only related to function. You simply do not ever create that level of precision in order to chase form. It's just simply too expensive to develop that degree of precision for that purpose. There must be a function that pays off that investment in seeking that level of precision. And this is the level of precision that we are looking at when we look at the inside surfaces of these boxes. It's kind of mind-blowing when you consider it. Christopher Dunn understands this concept extremely well. He's been involved in the manufacture and use of highly precise objects for the aerospace industry for a long time. And he is one of the few people that have even attempted to understand the degree of precision that is shown on the inside surfaces of these boxes. And what he's found is frankly astonishing. In order to illustrate his findings, I've done a little bit of 3D modeling of one of the boxes in the Serapeum based on Christopher Dunn's measurements. You can see the little man standing there. And I'd like to quote a little bit from Chris Dunn's book, Lost Technologies of Ancient Egypt, about some of the measurements that he took from the inside of Marriott's dynamited box. Quote, "With permission from my host, I climbed inside the box with the opening in the corner and took my gauges out of my backpack. I had with me a solid precision square that had a 14-inch or 35.56 centimeter blade. The square had been calibrated to be accurate within 0.00005 inch or 0.00127 millimeters in square. I wiped the dust from the surface of the granite with a damp t-shirt, placed the square against the underside of the lid, and brought the blade in contact with the inside of the box. When I shined a flashlight behind the blade, I did not detect any gap or imprecision on either the lid or the inside surface of the box. Gail Fallon took a photograph while I held the flashlight to illuminate the square. As seen, the granite surface was finely tooled to a mirror finish. The reflection off the granite surface indicates an optical accuracy. There are no distortions or aberrations in the reflected image." End quote. What he found was that the inside walls of the box and the lid are perfectly square to one another. What is even more astonishing is that the inside walls are also square and parallel to each other, which is really incredible when you consider they are all carved from a single piece of stone. Consider the two end walls in the box. These walls are around 10 feet apart. Keeping them perfectly parallel to each other is a real achievement, and it's just not something that is achievable without incredibly precise measurement tools and all sorts of technology that we just can't attribute to the ancient Egyptians doing it by hand. Again, Christopher Dunn. Quote, "The difficulty in creating this object should not be brushed aside, because upon measuring the opposite wall, I noted that it too is flat and square with the underside of the lid, which means that the vertical surfaces had to be crafted parallel to each other. Such perfection is not an accident and cannot be produced with the tools found in the archaeological record." End quote. In addition to being square, the walls are also perfectly flat as far as we can tell. Chris Dunn used a precision straight edge calibrated to within 1/20th the width of a human hair to measure sections of the wall, at least as many parts of the wall that you can waft a straight edge over, and he found no areas where light escaped from underneath this precision straight edge, which means that within that 12 or 18 inches of the straight edge, the wall is completely flat. This is absolutely crying out for more scientific investigation, and he says so, further quoting from his book. Quote, "The results, however, do command attention and should encourage further inspection using more sophisticated metrology instruments, such as autocollimators and specialized laser alignment equipment that can provide surface mapping and orthogonal tolerances." End quote. Now, of course, this inspection has never happened as far as I know. So far, we've determined that the walls of the inside of these boxes are perfectly flat, and that the surfaces and the lid are perfectly square and parallel relative to each other. There's one other aspect of precision that I'd like to explore, and that is the inside corner radiuses of the box cavity itself. Once more, Christopher Dunn. Quote, "I did use a Brown and Sharp radius gauge to inspect the corner radius where the two surfaces met. I can testify that when I went through my set of radius gauges in order to select the closest fit, the 5/32 of an inch or 4mm radius gauge fits snugly in the corner. The inside corners of the boxes are a confounding puzzle. I wondered why craftsmen would take the time and trouble to work out the corner to a small radius of 5/32 of an inch. In layman's terms, a round pencil would fit very nicely in the corner. For the assumed purposes of the box, the resting place of an Apis bull carcass, a 24-inch radius would leave plenty of room for the bovine deity. It doesn't make sense to work out the corners to such a small dimension. Next, to make sure that the inside surface of the box was perfectly flat to the tangency point of the radius causes great consternation among technologists who are familiar with this kind of work. The added cost of having a 5/32 inch radius as opposed to a 24-inch radius would be astronomical if the material was worked by hand." End quote. As a simple example of this, I have here a couple of cross sections of boxes showing an example of what a square corner would look like, and then a rounded corner that is approximately a 24-inch radius. You can see the kind of effort that it would take to make sure those corners are square, or at least finish down to a 4mm inside radius. It's absolutely crazy. It would require so much work and so much attention to detail, and you can't make any mistakes. Remember that all of these boxes and these corners are carved from a single piece of stone. If you make a mistake in one place, now you have to change the geometry of all the other walls and corners. It's just simply not achievable to do this type of thing just by hand or with primitive tools. It certainly doesn't make any sense if all you're doing is building a funeral box for a bull that you're going to seal up once and bury and forget about for all time. In order to illustrate this one last time, let me quote Christopher Dunn. Quote, "The engineering context of precision, where precision is not necessary, indicates the existence of sophisticated tools. These have not been found in the archaeological record, but the existence of them must be taken into account when we consider the mountain of circumstantial evidence to support their use. In the case of the Serapeum, the list of tools and instruments that are necessary to create the granite boxes has grown. We can say with certainty that exact measuring instruments existed, for this work and the work at Luxor and Karnak could not have been accomplished without them. They are the most important and necessary tools for such work. The wooden squares, plumb bobs, and alignment instruments on display in the Luxor and Cairo museums are incapable of giving even the most talented craftsman the information he needs to know that his work has achieved this kind of accuracy." End quote. The certainty expressed by Chris Dunn here, that there is absolutely no chance the tools on display in the museum are responsible for the precision and the work that we can see in places like the Serapeum, is a sentiment that's shared by many of the tradespeople, engineers, craftsmen, stonemasons that get to visit these sites. So who should we believe when it comes to interpreting the origin story of this place based on the evidence we have in front of us? Is it the Egyptologists, the academics? Or is it the engineers, the stonemasons, the tradespeople that likely built this place thousands of years ago? At least for me, logic and reason leaves me at the conclusion that we must be looking at a mystery. This is a clear contradiction between what we see and what we're told. And with this simple acknowledgement, the search for the real truth at the Serapeum could begin. And clap. So I hope you all enjoyed that. Please let me know what you think in the comment section below. I do read all of the comments. Stick with me in this series. I hope you join me for the next video in this series. I'm going to take a look at a couple more features on the outsides of these boxes and what I think is the real dead giveaway that there's some form of ancient high technology in use, the polishing or the finishing of the boxes. And I want to give a huge thank you to everybody that has reached out and supported me via Patreon or via PayPal. I really do appreciate it a whole lot, particularly in these early days of the channel where I'm trying to get things started. As I'm publishing this, I'm closing in on 1,000 subs. I'm really looking forward to that milestone, so thank you to everybody who has subscribed to the channel. So if you enjoyed this, please do consider supporting me via the value for value model, which goes along the lines of if you got some value from my work, please consider returning a little bit of that value to me. You can find out all the ways to do that on unchartedx.com/support. There's a link to my tip jar on PayPal. You can consider that like tipping a server or maybe the price of a cup of coffee. or perhaps even the price of a movie ticket if you got some entertainment from it. If you think my goals are worthwhile over the long term, you can support me by signing up for a subscription on Patreon or on Subscribestar. I'm a one-man band. I do believe there's both a want and a need for high-quality content in this space, and a lot of time, effort, and frankly money goes into making these videos. At this point, they're the result of years of work. And I really do appreciate anyone that supports me in my goal of trying to continue making that happen. It absolutely helps me out. I've got a lot planned, so until the next time, peace.